Good afternoon, everybody. Well done for managing to stay the course so far. We've lost a couple of people there, unfortunately, but not to worry. My name is Chris Porter. I'm from Wind Direct. Our business is part of the Wind Prospect Group. Just in terms of a few credentials to begin with, we've consented over 2,000 megawatts of large-scale wind projects. We're very much in the 80, 100, 130 metre high projects. We've probably built just about the same number. Wind Direct is focusing on on-site generation projects, so that's 1 or 2 turbines on industrial sites. As a group, we have a 90% planning success rate, thereabouts, in an industry where it's normally somewhere between 20 and 30%. I don't have as many years in the industry as Rod does, about half as many, and I regret to say it's not getting any easier. So what I'm going to talk about, well, surprisingly, the first thing I'd like you to do is actually reject wind. I think it's very, very important to people to understand that probably the best thing you can put on your site is a wind turbine in terms of saving money. The problem is it's one of the most difficult. So when you're considering all these different options, then have a look at wind first and reject it as a non-starter. Because if it just happens to be one and it does actually work, then the opportunity is absolutely immense. What I hope you'll go away with today is that we heard right at the beginning about get expert advice. These projects don't get any easier. It's an extremely complex process. And I'm just going to give you a few snippets as we go along of how complicated it is. I'm not going to spend much time on development. In terms of wind resource, I'll talk about that a little bit. Buying a turbine. Is it the same as just going down to Tesco's and saying, all right, I'll have one of these turbines? By the time I've finished, you might be dissuaded that it's not quite like that. And then actually building a turbine, I'm going to take you through a series of a case study on a site we've just built up in Scotland. So in terms of the process, the end result is clear. What we're trying to do is have a spinning turbine to save electricity and hopefully make a little bit of money. We have to go through a process to get there. And today's focus is more from planning onwards in terms of getting towards financial close and ultimately building the turbine. Just a question, did anybody manage to get any tickets for the Olympics? Would you like to put your hands up if you got any tickets? Well, 1 or 2. I'm delighted you got some tickets because being an Olympian, it's pretty difficult for us to get tickets in this country, but actually getting to the Olympics is a major challenge. In fact, it's a major hurdle. And winning it is, it's 1 in a million chance. And that's a little bit like getting planning for a wind turbine. So this is my hurdler who is completely focused on trying to get to this very valuable planning consent. The sorts of hurdles that have to be jumped successfully may turn out to be the MOD or railways, pylons, ecology, birds, bats, newts, badgers, butterflies, otters, it goes on, have to be resolved. Microwave links is about Orange, and it's about Vodafone, it's about data links. Cultural heritage, I come from Hadrian's Wall country, a World Heritage site, a major challenge if you're going to put turbines there. Noise, do turbines make lots of noise? Well, the public tend to think so, but if you're going to stand underneath a turbine, I could take this microphone off, we could have a conversation, and you wouldn't be drowned out. Very much about perception. Housing, can't be too close. Shadow flicker, noise, visual impact. And when you've solved those problems, just a few more to worry about. Cumulative impact. Access, can you get the blades there? These blades can be 40 or 50 metres long. The local planners, what do they think? So these are just a few of the hurdles that one has to get over to get to development and get a consent. Just to give you some numbers, we looked at 6,000 sites 3 or 4 weeks ago. We then assessed them according to the various parameters which you've got up there. We got down to 97. Of those 97, if I got one built, I'd have done a fantastic job. That's how difficult it is. But what about resource? We touched on resource earlier. Resource is fundamental to a project. You can start with looking at maps and wind resource and basically guess it. You can get satellite data. You can look at NOABL, that's the national database. Regrettably, there's only one sure thing about NOABL, and that it's wrong. So you're actually into guessing what the wind speed is. But if that's all you've got, then that's all you can use to start with. Putting an anemometer up is a much better idea. You need to get planning for it. It's over 10 meters high, and you want to have it up there for as long as you possibly can. A year of data is very valuable, and you're going to see why in a moment. You can also use the anemometer to look at the wind speed to start plotting noise when you get the noise output of a turbine, just to prove that it isn't going to be noisy. The reason why you need this is because you need to be able to work out the yield. So how many megawatt hours of electricity have we got? You heard that right at the beginning today. It's not that it's a 6 kilowatt machine or a 5 kilowatt machine. What it's about is the actual yield. And the person who wants to know that is the person taking the risk on the project. Effectively, the wind, this free resource, is actually the key to the project, because somebody is going to have to put their hands in their pocket to fund this project. And the funder will be very, very interested in the yield on that turbine, because ultimately that's what's going to bankroll it. The model of turbine is critical as well. Different turbines behave differently in different wind regimes. I'm going to show you some examples of that in a moment. So getting the resource right is critical. And the reason it's so critical is because you have a thing called a power curve. And this is the power curve of the machine. You've got your wind speed along the bottom here, and you've got the output going up on the y-axis. Having a turbine which is running at 16 meters per second on this particular power curve or more is a complete waste of time, because obviously it doesn't go any higher. What we need to do on this particular one, this particular wind speed, is actually get something which is in this area here. You have low wind speed turbines, high wind speed turbines. That's just one of the elements that you need to consider in terms of buying your turbine. But also, more importantly, in case a turbine manufacturer will actually sell you a turbine. It isn't a question of just going to Tesco's and saying, I'll have one of these, please. The first thing you've got to find out is who will actually sell me one. A major problem which, certainly when I came into the industry 10 years ago, I couldn't believe that, people wouldn't be queuing up the door to actually sell me a turbine. Not like that. What the turbine manufacturer needs to know are several things. They need to know, what's the absolute maximum wind speed that we've measured? What's the extreme wind speed? What's the mean wind speed? Those are pretty obvious. But what about the turbulence intensity? Don't want to get technical, but what this is a graph showing over a year in 10-minute slots what the turbulence intensity is. So we've got the wind speed along here, the turbulence intensity on the y-axis. Every single one of these dots, these blue dots, is a point showing what the intensity is over that year, over those 10-minute spells. What we've then plotted against it is the typical capacities or robustness of particular models of turbines. Turbines can be measured according to an international classification. So you've got different categories, A, B, and C. What one needs to do is make sure that your turbine will fit within the turbulence intensity design life for that turbine. So it's not a 5-minute job just to work this out and get one off the shelf. Of course, when you've decided on your turbine, the turbulence intensity, particularly if this is on an industrial site, then clearly you're going to expect there are going to be some buildings on the site. One way of working out what's going to happen for the turbine manufacturer is to say, well, actually, we need to model this site, because it would look very nice to put a turbine in here, and we'll know what the wind speed is, we'll know what the turbulence intensity is, blowing around all these buildings and skyscrapers on the site. But something different might happen in the future. Somebody might, in their right mind, might decide that they're going to put a whole load of buildings here. What's going to be the impact on the turbine? Hopefully not too much. But how are you going to work that out? Well, the way you work it out is you put the model into a wind tunnel and you measure it. This is some pretty sophisticated technology which has been used for, obviously, racing cars. And you can measure the impact of the turbulence of those buildings on the turbulence intensity graph such that you can select your turbine. So if anybody's thinking that turbine selection and procurement is easy, then I hope that just gives you one very tiny example. It isn't. So, having solved all those issues, and will it fit from the robustness perspective, you then get into the contractual side. I'm not proposing to go through all those different things, but the warranty liability, the noise, the power performance, permitting, absolutely vital in choosing your turbine and getting the right turbine for the job. When you've got to there, then clearly we need to put a business case together, and this is relatively straightforward, or I would hope it is. From a revenue perspective, clearly we've got the feed-in tariff, we've got the ROC, we've got the LEC, the energy used or exported. Those are your top line. In terms of capital, those are some rough costs all in for turbines. In terms of operations, don't forget that. You're talking to maybe about £100,000 to £150,000 a year just in terms of operational cost. Covers your business rates, your insurance, the actual maintenance, the visiting of the turbine. In terms of those project costs, those are built up over a number of different things. It's not surprising that the turbine is going to be the most expensive part of the project. Perhaps the surprising part is this bit here. This is the part where you're trying to get to financial close, to find a partner who's going to fund this or to fund it yourselves. This is the grid connection, it's insurances, it's legal fees, it's the detailed design, it's doing all the risk assessments, it's mitigating against that risk, it's talking to the funder to make sure they're completely happy in investing in the project. There is a significant amount of money tied up in there, and without it, and without those documents, the project will not fly. We've just closed a project down in Suffolk about a couple of months ago. There were effectively 60 contracts which had to be signed between all the different parties in that phase. Now you imagine the knock-on effect of all those on each other. It's a major challenge. So if I haven't frightened you now, then, well, excellent news. So let's go build it. I'm going to do a short case study now on a company called FMC up in Dunfermline. They're in the oil and gas sector, very environmentally aware. We're very, very keen from a carbon reduction perspective to have a turbine on their site. They also have a thing called the Green Shoots Fund, which is trying to plough back money into green projects. And certainly it's a sign of how progressive they are. You remember the signs at the beginning showing how difficult it was to get turbines on a site. Well, just a brief development perspective of this. This was their site, this is their factory, and unfortunately we had a whole load of buffers on this site. So it looked like quite a big site to begin with, but we had gas mains on this side, which basically this buffer took out all this part of the site. The red line represents houses, so there were houses over on the left-hand side. This is a railway buffer we have. So the only space we had left within the site is this area here. And this was bang in the middle of the operations of their site. So would you normally put a turbine there? Probably not, but they were keen to do it. So were we. So that was the spot where we had to put the turbine. So we started digging up in their yard, and this is the foundation. We then started backfilling it with reinforcement, obviously concrete. There was a cofferdam on there to make life easier. Having backfilled, start filling with concrete, obviously. These are the cable routes which are coming out into the substation on the site. And then it was all nice and neat and tidy, and their yard was reinstated. And you can see the turbine base takes up a relatively small area within the site. So their operations still could go on around it apart from that area. The tower sections then arrive. These tower sections might be 20 to 30 metres long, depending on the size of the turbine. And then the blades arrive. They don't bend. The biggest cause of delay on the FMC project was the wind. We couldn't get the blades across the Forth Road Bridge. We were then waiting to put them up, and unfortunately it was windy again. So we had to delay another week, so we lost production there. But there's nothing much you can do about that. The tower section then goes up. Big cranes on the site. And this gives you an idea of the factory in the background, the tower section. We've actually had to lay the blades down in three, all joined together, down one side of the factory, down the other side of the factory, and then sticking out into a spare space which they had. I love this picture. It just shows how complicated it all is. We've got a man down here grouting the base at the time, and the crane ready to lift in the final tower section, which is there. We've got a nacelle here, which then goes on the top, and then the blades, which then fit onto the top of that. It just shows you how complicated it is. We did stop the operations on the site for this part for probably a couple of weeks, but then given you've got 25 years of operation, then that's a price worth paying. And then that's the final picture showing the site itself. The turbine sits there producing roughly 40% of the energy for the site, saving loads of carbon. Now, a key part which I've not really talked about is why did they actually bother? Well, the reason they bothered is because when Mr. Putin turns his gas taps on and off, then what happens is we have this fluctuating energy price. And however clever you are as buyers, unfortunately, dealing with Mr. Putin, dealing with tsunamis, the price of gas, oil, shale gas, whatever it might be, you're not going to ultimately beat the long-term trend. The beauty of on-site wind, of course, is that when you know what the capital cost is and you know what the wind regime is and you can predict the yield, you've actually got a stable price for your electricity. The only variable cost you've got is the operation and maintenance. WindDirect put turbines up free of charge, and inevitably people have to justify that. The beauty of wind, and this is why I would suggest that you reject it straight away if it really isn't possible, is that you can normally reduce that price. Typical price for wind generation on a free of charge project, somewhere between 4 and 6 pence per kilowatt hour long term. There are not many people that can beat that. In terms of taking advantage, there are two ways of doing these projects. You can either do it yourself or you can get somebody else to do it for you. Most people try to concentrate on core business. That's where probably the money is to be made. Typically these projects, you're getting an 8 or 9 year payback. It's not awfully exciting. So a piece of capital equipment, a piece of production machinery is a lot more exciting to invest in. These people are all doing it free. Hasn't cost them a penny or will not cost them a penny. What they've seen is that actually this job is very, very complex. So, overall, to summarise, it is very complex. Resource, you do need to get and understand and to make sure that you know what you're actually going to get to be able to give it to your funder. Purchasing turbines isn't like going down to Tesco's. Building it is equally problematical. However, it could well be that you've got hidden assets on your sites. The important thing is to get them checked out. For those of you with smartphones, if you get onto that QR code, it'll automatically take you to a site where you can actually check out whether your site can be done. For those of you who don't have them, you've got one of these on your chair. It's got the website on it for you. There's even a free wind turbine inside as well if you want to take it home with you. For anybody who wants to know more about wind turbines, we run a series of webinars. Fill your name in on here, drop it in on our stand, which is just over there. Guess what? It's got a wind turbine on it, and we'll gladly keep you in touch with any webinars we're running. I think questions are going to be taken later on, so I'll come and sit down, but thank you for your time.